Hello friends, good evening all of you. So today video we are going to say about the combinational circuit and sequential circuit from unit to computer system architecture. So already we have completed what is the simplification and came up a concept also. That's very important, I said already. Okay, we can move on to the session now. What is combinational circuit and sequential circuit? First one we are going to see combinational circuit. So combinational circuit means just we can say directly it will take only present inputs. It won't take any past values. So automatically it won't take any past values means automatically no need any memory here. That is the thing, it's a combinational circuit. So here you can see definition. Sometimes they will ask definition directly and they will ask you the questions. That's the thing. Really sometimes will happen. Statement based questions. So a combinational circuit is a digital logic circuit in which the output depends only on present input values. I have marked a bold, actually you can see that's very important. So present input values only it will take. It won't take any past values. Okay, it does not store any previous informations because it has no memory elements. Actually no need actually. So whenever the input changes, the output also change immediately according to the implemented the logic function. Okay, so again I'll tell you some theory questions. They will ask you definition directly and they will ask whether that is combinational or sequential circuit. So definition, the combinational circuit is a digital circuit whose output is determined entirely by the current combinations of input signals. So what are the characteristics? So here it's very important, actually characteristics we need to know. So the output depends only on the present inputs. Yes, already we saw that one. So does not contain any memory elements such as like flip-flops, latches. And one more questions really we have to understand which one is sequential circuit and which one is combinational circuit. For example, here we can take flip-flops and latches and these are the things, registers, these are the everything is the sequential circuit. And we can take its adder, subtractor that we are going to see next one. Multiplexer, demultiplexer, coder, encoder. So decoder, everything is under it will come in the combinational circuit. Okay. Okay, no feedback paths is present. So whenever we have it's a memory element or something, so from there we have to, it will take from the inputs. Yes. So there we will have to need is a feedback path. Here no need actually. So does not require any clock signals and produce immediate output after a small propagation delay. So mainly used for arithmetic and logical operations, this one. So you can see the diagram, n input variables and m output variables. And just whatever present input it will take and it will work out using combinational logic circuits. Combinational means we will take it's a different types of logic gates we are going to use. So first itself I told you logic gates we have to understand clearly. In first class itself I have taken that one. Okay, current inputs and it will work out and it will give depends on the output. That is the combinational logic circuit. Okay, what is the advantages? So simple to design and implement. It's no need so much of tough actually because we don't have any memory, so nothing, so no nothing feedback anything. So it's going to take inputs and going to work out the output. That's all. High operating speed. Require fewer hardware components only and easy to analyze and troubleshoot. So lower power consumption compared to sequential circuits. So anyway, we are going to see sequential circuits. It will be, we can identify better. Okay, what are the disadvantages? So cannot remember previous inputs. So obviously we don't have the pre-memory. So automatically we don't have in the past, we are not going to take any past values. Yes. So not suitable for operations requiring data storage. So not applicable for data storage. Circuit complexity increases as the number of inputs increases. So it depends on the input increases, the circuit complexity also will change here. It's everything depends on the present input. That's all. Okay, common applications. That's why this is the applications we have to know, because very simple questions they will ask you, whether multiplexer, whether this is RMUX, they will ask you, whether this is a combinational or a sequential circuit. Okay, this is very easy questions only, but some easy questions only we won't actually give so much of importance. That's why I'm telling it's a very often asking these questions, even net exam and set exam also. So adder, subtractor, multiplexers, demultiplexers. So that subname, another name also we have to know, mux and demux. Encoders, decoders, comparators, and code converters. These are the application for this a combinational logic circuit. Next one, sequential circuit. A sequential circuit is a digital circuit in which the output depends on both the current inputs and previous states of the circuit. So it has memory actually. So whenever we are taking previous statements, automatically there it has a memory. So from memory only we have to take the previous or past state. Yes, so it contains memory elements to store information, allowing the circuit to remember past events. So definition, the sequential circuit is a digital circuit whose output depends on the current input and previously stored information. Why? Because just have written definitions, because simply they will ask you in statement question definition and they will ask you whether this is which type of circuit, but they won't give this is term only, that's all. Okay. And what are the characteristics? This is a diagram actually. So here it will take the present input as well as, once again. So here it will take present input as well as it will go to the memory also, memory element also. From there also it will take this one. So this is the term actually. Okay. So it has memory elements and it has feedback also that we have to identify. That's why characteristics very important. So keywords. Already I told you theory based questions, full and full keywords, one of the gift actually. So output depends on current inputs and previous states. Contains memory elements such as flip-flops or latches. So usually operates with a clock signal. So it has feedback paths. So store informations are future operations also, and used where sequence and timings are important. Okay, what are the advantages? So can store previous information and suitable for time dependent operations, perform complex operations involving sequences, widely used in digital systems and processor. Even processor we can take that as a register. What are the disadvantages? So more complex to design compared to combinational circuit. It's a more complex one and require memory component, need clock synchronization in flip-flops, everything. Just you can see we have the clock signals, everything. So clock synchronization we are using here. Slightly slower because of the clock and memory delays. Consumes more power than combinational circuits. Okay, so what is the common applications as a flip-flop, registers, counters, and counters? We have different types of counters, ring counters like this. Even they will ask you types of counters, any types of counters they will ask, and whether this counter is it's under sequential or combinational circuit. Also, they can ask. They won't ask you directly counters also. So we have to remind that even that part of the subparts also it's under into the counters also, this under into the sequential circuit. Yes, and shift registers, finite state machines. Finite state machines actually we are going to see in the TOC, theory of computation paper. It's very interesting paper actually. Normally we used to say tough paper, but it's a calculative based paper. Really it will be very interesting if we can understand. So that also we are going to cover. Next, digital clocks and traffic signal controllers and memory unit. So these are the applications for this one, sequential circuits. And what are the difference? This is very important table, just exam oriented concept. Just while going exam, this type of tables, this type of diagrams, and I used to say many places it's exam oriented. So these are the things just you can keep, and before exams just you can read and go Really, it will be very helpful. Like many places, for example, data structure, we can take time complexity. TOC, we can take some diagrams and some tables, type 1, type 2 grammars. And like this, every subjects, every papers, units, we have the important concept. Even discrete mathematics, already I told you that the formulas I'll give you. So these are the things we have to remember for exam purpose. Okay, so what is the definition? So that's the output one depends only on current input. So here output depends on current input as well as previous data. What is memory? Here no memory, no memory needed. Here contains memory element. Past input dependency not considered. Here input affects the out. Previous input affects the output. Clock signal here, no clock signal required, usually required. Feedback here, no feedback here, feedback path is present. Output changes immediately with input changes according to the clock signal and stored out data. Complexity is actually this combinational simple design. This more complex design. Speed actually this is faster. This comparatively that one is slower. Power consumption lower. It's a higher it will take. Applications you can take arithmetic and logic operations here. Here storage, counting, sequencing, and control operations. Example adders, multiplexers, decoders, encoders, comparator, and already we said. Here flip-flops, counters, registers, finite state machine, shift registers like this. And so just today I'm going to start what is full adder, half adder, full subtractor, half subtractor, everything just a definition. So tomorrow next videos onwards we are going to see separately one by one what is full and full definition with examples everything. First one half adder, just I didn't write actually. So the half adder here simply I've written is used to add only two numbers. Yes. So to overcome these problems, the full adder was developed. So it is used for add full adder. Why it's add three one-bit binary numbers A, B, C, and carry C also. So this working procedures, everything we are going to see separately the upcoming videos. The full adder has three input states and two output states, that is sum and carry. What is half subtractor? The same thing like half adder. Here half subtractor is the building blocks of subtracting two binary numbers. It won't allow three numbers. So that is called different and borrow only. So that purpose only we have it as for it's going for full subtractor. So again I see half subtractor is used to subtract only two numbers. To overcome this problem, full subtractor was designed. So the full subtractor is used to subtract three one-bit numbers A, B, and C, which is minuend, subtrahend, and borrow. Okay. And multiplexers are. Multiplexers is a combinational circuit that has n data inputs and single output. Actually, multiplexers and encode is very important question. Simply, they will ask you 2 power n equal to n. Which one is match the following? It's a very frequent, important question. It's also known as data selector, which selects one input from the inputs and routes to the output. So with the help of selected inputs, one input line from the n input lines is selected. Okay, maybe just I'm reading out this, just we can see one by one, so elaborately just with example we can see upcoming videos. And demultiplexers. Demultiplexers nothing but it's the opposite term of multiplexers. Normally I used to say for this one multiplexers and demultiplexers, just we can read it one thing, anyone multiplexers. And decoders and encoders are opposite terms only. So we can read decoders, automatically we can come to know where the encoder terms. So a demultiplexer performs a reverse operation of a multiplexer. The demultiplexer has only one input which is distributed over several outputs. So okay, decoder means it's a combinational circuit, n inputs and maximum m equal to 2 power n outputs. So like this, an encoder is a terms of opposite to decoder. Okay, so this is the term just we have seen. So next class we are going to define full and full separately. What is half subtract, half adder, full adder with example of subtractor, full subtractor. Like this, everything we are going to see, even sequential circuit, flip-flops, counters, that types, working procedures, everything. and side by side we can cover PYQs also. Today just I've taken small concept. And again, I want to say it's a very important thing. Coming August, I think notification will get for set exam, and December we are going to write net exam. So it's the right time to study for net and set is a dual. This one, it's a double use purpose actually. Okay, if you have any doubts, just you can post in the comment section. And thank you all of you. Thank you once again.